Welcome back to Isifundi Training and Bite-Sized Corrosion. You will notice we've got a little bit of a camera gremlin, and we're going to carry on our conversation despite the fact that the camera is not working. So, as you know, I'm Vanessa Seeley-Fisher, and it really is a delight to host today's discussion. And whether you are a professional working with high-tech coatings on a daily basis, or if this is a subject which is fairly new to you, as it was to me when we started, I know that you're going to find valuable insights during today's discussion. We are almost at the end of our 6-session conversation looking at high-tech coatings. Today, we're going to shift our discussion a little, focusing on some wear-resistant coatings. Obviously, these coatings are particularly useful when the environment is somewhat abrasive, perhaps due to high winds and sands being blown, or maybe in the mining industry in particular, due to thick slurries. And in these situations, not only are we applying the coating to protect our structure from corrosion, but we're also applying it to help us reduce the effects of abrasion, to reduce any effects of friction in the case of, for example, a slurry pipeline, and in order to make sure that the coating also assists the structure in ensuring that what we are trying to move in our structure, in our pipeline, doesn't cause excessive wear damage as well as corrosion damage. Now, there are many applications for a variety of rubber linings, polyurethanes, but a type of coating that we haven't yet discussed during this series is that of ceramics. And I'm really delighted to be able to welcome George Clack from MIET Group of companies. He's come today to help us explore some of these ceramic coatings a little more. So thank you, George, for joining us.
Thank you very much for the opportunity, Vanessa. I will tell you more about ceramics in a moment.
George, I thought it would be worthwhile to explore, in particular, what are termed chemically bonded phosphate ceramics in some detail. Now, that's quite a mouthful of a name, and I wondered if you could just break it down a little for us.
Yes, sure. Just as an intro, I always ask, where is it coming from? In short, it was formulated and designed by American scientists in the late 1990s to encapsulate radioactive waste. And that's where ion coat exists from. So you can imagine if you take a carbon steel container and you put radioactive waste in it and you put it in the ground, it's supposed to never come out for thousands of years. But that's where ion coats come from. Now, if we look at ion coat is in short abbreviation CBPC. It's a chemical bonded phosphate ceramic. Ion coat is a water-based 2-part 1-coat system. It's essentially an acid phosphate which is combined with some base minerals and metal oxides, and it's spray applied by a pleural pump. As the two parts will mix, it will create an exothermic reaction, and it can create heat up to 8 degrees. To break it down, ion coat is fundamentally totally new technology which chemically bonds to the top layer of the steel by alloying metal oxides to non-alloy steel or iron. That's quite a mouthful. In short, if you compare it to anything else on the market that we used for 100 years, everything on prep steel sits on prep steel with adhesion. Ion coat was designed as it hits on the surface of the steel. It creates a new alloy on the steel by binding with the ions in the steel, forming a new layer that cannot corrode. That's why we add its permanent corrosion protection. This process of alloying metal oxides to non-alloy steel or iron forms that inert layer that I talked, and that can no longer react to oxygen or moisture, resulting in permanent corrosion protection, and it cures in 15 minutes.
So essentially, you've got these two components that you've mixed together, and in the alloying process, you've got a metal alloy forming on the surface and then a ceramic forming on the top. Have I understood that correctly?
Yes, you are 100% right. The first layer that forms in a few seconds chemically bonds with the ions in the steel, and it makes about a 5 to 8 micron new alloyed layer on the steel. So physically what happens is changes the structure of the steel. It is part of the steel. And then on top of that, form a dense magnesium phosphate ceramic layer that is there to protect that first passive layer by leaching phosphates onto it the whole time. That's basically what ion coat is.
Okay, so in concept, actually, This is very similar to the galvanizing reaction, where in galvanizing our zinc actually alloys directly with the steel, forming various zinc iron alloys. And in the case of galvanizing, if you were to scratch or to damage through the galvanizing onto the steel, it self-heals and the corrosion itself is halted. And so if I'm understanding you correctly, you're describing something fairly similar. Now, would that demonstrate the same thing if we scratched through this phosphate ceramic to the steel? Will we get the same kind of response?
Yes, Vanessa, exactly what happened. Ion coat is also defined as self-healing. So basically what happens, if you scratch the steel right through the ceramic and the first layer into the base steel, it will rust there automatically.
Okay.
But what will happen, if that scratch is not too big, the phosphates in the ceramic will leach onto that damaged area, and it will bind with the ions in the steel and fixing the passive layer. In other words, it's fixing itself.
Okay.
The second characteristic of it is that it can never creep under the surface of the passive layer. It cannot. Rust cannot creep in it. Guys like NASA has tested it, and Chevron, and they say it can't creep or that type of thing.
I can understand that, because if you've got an alloyed layer, in the same way that rust doesn't creep under zinc, a zinc galvanized surface, it'll be exactly the same concept until, I suppose, all the phosphate was leached out, which one imagines would take quite some time, because we don't have that anodic reaction as we do with the zinc. George, in looking at how to apply this phosphate ceramic, would your surface need to be particularly clean? Are you looking at a steel surface that needs to be an SA3 like we need for some of the organic coatings, or are there less stringent requirements?
There's basically 2 points that you can approach on that. The first one, if you, for instance, let's take a tank that is rusted and it stands there, it is new, it's rusted, there's no paint on it, and it's carbon steel only. Then you will do a commercial blast of SA2 on it. Ion coat requires a minimum of a 75mm profile to work on it. But the carbon steel will be sandblasted or vapor blasted. And after that, you will just use normal HP washer, 3000 PSI HP washer. And you will wash the surface. And while it's damp, you can start to spray ion coat.
Okay, so you can work on surfaces that are slightly moist. And is that because there's a need for water in the curing reaction as well?
Yes. Ion coat is a cementitious product. If you take, for example, it's cement.
Okay.
It looks like paint, spray like paint, but it's not paint. It's actually a cement. So all of us has used cement and mixed some sand with it and water. If there's too much more water, the cement doesn't work. If there's too less water, the cement will crack. So with ion coat is the same. Depending on the environment and the conditions, I'm talking about heat and wind and heat on substrate, the applicator will see that the ion coat that is spraying must have enough moisture in it for at least 15 minutes. So if you work on, for example, very heated day, and you work somewhere up in Africa, even here by us where the substrate is get very hot, then we will just mist the substrate to cool it down, and the substrate must be very clean, and then you can spray ion coat. It's actually a very forgiving if you do the prep right, and it takes quicker.
I'm smiling because on a normal day in Gauteng, I agree with you, it's very hot on a summer's day, and we'll need to do some misting. But the weather at the moment is just pouring with rain, and so no additional misting would be required if we were spraying it today.
That's the fantastic thing about it. While you're speaking about the weather, besides rain, in any condition where you can't really apply anything else, ion coat, it doesn't matter on the weather. You can work.
Right. Okay. Well, that's very interesting. Thank you for that information, George. Now, again, talking about these phosphate ceramics, and you've mentioned that they were sprayed with a pleural spray. Where does that leave us on the volatile organic compounds? You've mentioned water, so I'm presuming that there are very low, if any, VOCs. How does it stand on that?
Basically, ion coat is one of those products. Luckily, it was designed like it. It is certified a green product all over the world. So, and it's sprayed by a pleural system. There is absolutely no VOCs, no HAPs, and it's non-toxic. It does not burn. It does not give off gases or any odors. So it's safe for the environment as well as for our applicators.
That sounds like a good product to be starting to head in that direction. We've mentioned a little earlier that this is a cementitious product, and I'm having a little bit of a scary thought about spraying cement down these very expensive plural spray systems and the lines setting inside the system. How do you clean the spray equipment to make sure that you don't get your product sitting inside the equipment?
That's one of the easy things for the applicators. They love it all over the world. You clean it with water. Basically, what you do is that after you've done your application, you will flush the pump and the lines with water. And turbulence of the water also, it will take all the ion coat out. That's the fantastic thing about it.
Thank you for clarifying that. And then also associated with that, you mentioned a little bit earlier about 15 minutes needing to keep it wet. Is it a fairly easy, quick curing and fast application product?
Yes, it is absolutely fast. Ion coat, if you do the application with your spray, in 5 minutes time, you can basically touch it. Then it's like air dry. And in 15 minutes, it's cured. And in 1 hour after you painted a item, you can put it back in service.
Now, George, a question that's come in from the floor, which actually is a question that I had also thought of. You mentioned that the bonding between the phosphate ceramic and the steel is because of a chemical alloy bond that forms. Why then the necessity for a blast clean profile? So I think you mentioned something around 70 or 80 micron deep profile.
Micron.
Why would you need that profile?
To explain it nice, if I do a white metal blast, SA 2.5, I can spray ion coat on it. It also binds with the ions in the steel. But you will see that everyone that applies ion coat will let that white metal rather get a flash rust on it. Then it binds quicker and easier. But like for any good product out there, you do need the profile, even for ion coat.
Yeah, maybe there's another technical answer to the question, just because I'm also not exactly sure why there's a necessity for a profile if you're focusing on an alloying bonding mechanism. But I'm not going to let us get hung up by the technical question. We can perhaps do a little bit more research in that regard. I wanted to spend a little bit of time looking at if I can say, the second part of this phosphate ceramic, which is the ceramic part. And I confess my experience with ceramics is limited to maybe a little bit of dentistry, but let's not go there, but also to the kitchen. And in terms of kitchen ceramics, we're talking about something that's hard, that's heat resistant, but that they're also very brittle and very unforgiving. They have no flexibility. I mean, if you drop your Corningware or the non-branded equivalents that are available today, it shatters like into a million pieces, worse than glass. How does the ceramic that is formed in these phosphate ceramic coatings different from that? Is it a very brittle coating? And are there areas that we need to be concerned about in that regard?
Vanessa, ion coat was designed as part of the formula. It's got some fillers in and some other materials. Ion coat specific chemically bonded phosphate ceramics has got an elongation or ductility of about 18%. So you can drop it. It will definitely not shatter on the floor like the stuff in our kitchens. That's why it's ideal. If you look at big assets like storage tanks and bridges, there's a lot of movement in steel. Like yourself know, steel only needs 1% of true bending, then it can deform. But ion coat ductility elongation is about 18%. So it is designed to withstand that pressures.
So clearly the formulation, including the fillers, gives it that level of flexibility,
Yes.
which makes it more user-friendly. Well, that's quite helpful to know. George, another question that's come to us from the floor and leads into the next section that I wanted to chat about. Are these products tested and rated for contact with potable water?
Yes, 100%. Ion coat has got a ASTM certification. It defines as a green product. You can use it very near or next to potable water because it's absolutely safe.
Okay. So have you subjected it to the South African Bureau of Standards test certification or not yet?
No,
Not yet, okay.
we did not. There is quite a lot of certifications that we can supply that's been done all over the years from third parties, big companies, labs all over the world. And then, of course, everybody, one of the first questions they ask, have you got ISO 12944 certification, which is the common one that we all basically put paints and epoxies on? The answer is no. But the good thing about it is I think they started in November last year. They're busy making a certification for a chemical bonded phosphate ceramic because ion coat's not paint. It will also be ISO 12944 certification, but for a phosphate ceramic. But we can supply third party and all the certifications on a list to all people who want to have a look at it.
Now, we've looked at this coating and it does sound like a fabulous coating, but I'm also very aware with every coating, nothing in life is perfect, not me and not the coatings. Let's chat about some places where we probably would be unwise to use these phosphate ceramics. Where do they not work?
Remember, ion coat is a cementitious product. If we look at applications, you will use ion coat only on carbon steel. In the USA and also now in Australia and in Europe, they also do use it a lot on concrete, and you can spray it on polystyrene because it does not burn for that type of applications. But for normal applications, ion coat works with carbon steel, not stainless steel, not others. And then also ion coat, you will see all the applications, especially at the coast or wherever, is done above the waterline. With the ion coat as it is now, they are designing new ones that's got hydrophobic silicates in it. But you won't put it where there's turbulence, because the turbulence, if it's only ion coat that's on there, because ion coat is a primer and a top coat in one, it will eat away the ceramic. But the guys that got clever now, all over, they take ion coat, they put it on, and then they take special other products in the world, like certain tapes and certain epoxies, and they use it to top coat, ion coat. Then they stay with their goal. To the primary objective is to protect the acid, the steel, and just now and then they will fix up the top coat because the ion coat stays. It doesn't go away. It does its job. So
essentially what you're doing is you're adding in a level of mechanical protection by adding your petrolatum tape or your HDPE tapes, especially in the intertidal zones.
Absolutely. We've done now in the coal mines in Australia. Now I was busy in Nigeria, where they've got very, very acidic soil, and they want to put propane tanks in the soil. And we tested everything. Ion coat will do the job, but in the end, the chemicals in the ground, the pH is 4.5 and below, they will slowly starting to eat up the ceramic. So the guys took one of our major prominent suppliers that has a very good epoxy for sulfuric acids, and they top coat, ion coat, and they know now that in every 5 or 10 years, they will only work on the top coat and make it nice again. But the acid is protected and the ion coat's there.
If I'm understanding you correctly, it's not got great acid resistance at pHs which are very high, with very low pHs or high acidity.
Yeah, look, acidity or pH above 4.5 is good for ion coat. No problem. Ion coat is very, very good with chemicals. Ion coat is also good in the petrochemical industry, inside diesel and petrol and vegetable oil tanks, and that type of thing. It's very good with it. But nothing in the world is 100% proof. There's nothing that's proof. The nice thing about ion coat is that you can combine to really get a solution for the problem.
Right. Yes, one can imagine, because of it having that cementitious, which will be your high pHs, I can imagine that the acids will attack it. Wow, George, this has been a very, very interesting discussion. Thank you, and certainly opened our eyes to some different and really new high-tech coatings that are available. To be talking about a product that's had less than 30 years really since inception, you mentioned the early 90s, is quite forward thinking of the coatings industry, which prefers to cling to old, tried and trusted technologies. So thank you. As we close, George, I wondered if you have any interesting applications where chemically bonded phosphate ceramics have been used here in South Africa.
Yeah, sure. One really big application was for Astron Energy in Cape Town on one of those tanks, but it is a tank that is also insulated. We used ion coat on that. It was the first project in South Africa. There was a big write-up also on Nice Post on LinkedIn of all the ups and downs that we had doing this application. And ion coat does that all over the world. They don't just put the good stuff on the table. They said this went wrong, this went wrong, this went wrong. But in the end, the application they went quickly and fast. But Astron's got applications, and I'm very sure that in the next 3 months, there's a few projects that we're working on at the moment that will start up in South Africa, because it takes time for people to look at a new product. It doesn't matter what it is.
Well, certainly. Well, thank you so much, George, and thank you for helping us to understand how these chemically bonded phosphate ceramics function. It's been very illuminating to myself. You've certainly opened my eyes to some different applications and that there's so much more to learn. And I do hope that our audience feel that we've broadened your knowledge today on the topic and helped you to understand a little bit more about what you didn't know when we started.
I think it's a fantastic thing that you guys are driving here. And in the end, if we put all our heads together all over, then we will get better solutions.
Indeed. Thank you, George, and thank you for your time.